The visitor. Listen, there is a point in the dark where your eyes begin to invent. You search the sky long enough, and 1,000 ordinary stars will rearrange themselves into stories, a river, a hunter, a ship that never reaches shore. But every once in a long human age, something appears that is not a story we told ourselves. It is a story that arrives. On a cold night, beyond the orbit of the giant planets, a mote of ice found sunlight for the first time in a million miles. The light took hours to reach it, and only a heartbeat to reflect back. One pale glint, almost nothing, a whisper traveling through a sea of noise. On Earth, a sensor hummed, a line of numbers climbed by a fraction, and the world remained unaware. A single pixel shifted where no pixel should. It was enough. We did not greet it with trumpets. We greeted it with doubt. Software tried to erase it. Algorithms called it an error. But the error moved, and then it moved again and again, keeping time with a rhythm older than our calendars. The sky did not change. Our understanding did. Somewhere in a room lit by monitors, a scientist leaned closer and felt something that did not fit into equations. The animal hush before thunder, the breath held before a door opens by itself. Something had come. Not a satellite, not a defect, not a fragment thrown by our own restless machines. It came with a speed that did not belong to us and a path that did not bend to our familiar orbits. An outsider, cold, mute, indifferent, carrying with it the unsolved grammar of another sun. We named it as if naming could tame it. We numbered it as if numbers could make it less unknowable. We told ourselves stories about visitors because we are a species that survives by making the unknown into language. But there are arrivals that reduce language to a single small feeling, or with a shadow in it. Imagine its long sleep, not the sleep of a winter lake, not the frost on glass, but a sleep so complete that a century is only a footstep in an endless hallway. Imagine a body that knows nothing of our months or hours, guided by the tug of distant gravities, wrapped in ancient carbons, its surface painted by a radiation that has no memory of us. Imagine that this body has traveled longer than cities have stood, longer than our myths have had names, longer than the ancestors of our ancestors could count. And now it is here. Do not think of it as a comet yet. Forget the bright tales and hopeful wishes and postcards from the holidays of the sky. Think of it instead as a shard of elsewhere, a splinter from a distant room in a house too large to draw. It turns slowly, exhales invisibly, and the sun, our sun, the one we thought we understood, touches it like a match to a page, and something begins to burn green in the dark. We will tell each other that this is natural. We will list the molecules and trace the photons and show the spectra, because that is what it means to be awake in a universe like this, to measure where fear would rather bow. But underneath the methodical cadence of our measurements, there is the older music, a drum beat, quiet as a pulse, saying the same word again and again. Closer. It is not a threat. The ocean is not a threat when it is calm. The blade is not a threat when it lies on the table. But we know what water can do to stone, and we know what a blade can do to skin, and we know, in the way that migratory animals know the shapes of continents they will never see, that a traveler from far away does not need intention to change a world. It only needs momentum. Somewhere, a child will look up and ask a parent if the star has moved. Somewhere, a radio dish will turn on its slow axis and listen to a silence older than language. Somewhere, an observatory will fight clouds and time zones and fatigue to catch one more faint smear of light on one more frame. Somewhere, an old fear will shake itself awake, that we are small, that we are exposed, that the night is not ours. We will argue about names. Is it a comet, a rock, a messenger, an omen? We will argue about pronouns. Does it belong to us now that we have seen it? Does anything ever belong to anyone in a sky like this? We will argue because argument is a sign that something matters. And as we argue, it will keep coming, oblivious to our cleverness, obedient only to the geometry of the deep. Consider what it carries. Not technology, not intention, but memory. The memory of a furnace that is not our sun. The memory of winters that last for ages. The memory of collisions in a nursery of worlds where planets were dragged and broken and born. Dust holds history the way bones hold calcium, quietly, persistently, without permission. We will read that dust by starlight and call it science. The universe will call it weather. There will be headlines, of course. There will be an image that is not a portrait so much as a confession, a smear of light against a blackness that is never truly black. There will be an arrow, a label, a date, as if the ancient could be domesticated by captions. There will be those who shrug, and those who pray, and those who sell, and those who watch, and through them all runs a single hairline crack in the glass of ordinary life. The realization that we live in a place with doors. The first door opened when we learned to look. The second opens now, not by our hands, but by the passage of a stranger through the vestibule of our star. Maybe it will pass and leave us nothing but better numbers and a new line in the catalogue. Maybe it will gift us a thorn of truth we didn't expect, that the solar system is not a closed book, but a page in a library without walls. Maybe it will do what all great visitors do, reveal more about the hosts than themselves. Listen again. The instruments whisper, the servers breathe. The night air over the observatories smells like dust and cold metal. Far away, beyond the maps we teach in schools, a single body turns and exhales. Sunlight touches it and falls away like a hand sliding off a stranger's shoulder. In the time it takes you to blink, it has moved thousands of miles along a path written before we learn to write. Something is coming. Not from our skies, not from our stars, from somewhere we have never seen. The arrival. At first, it was nothing. A flicker, a faint change in brightness across a grid of stars, less than the breath of a photon. The telescope array in Chile had been scanning the same region of sky for hours, its purpose simple and noble: to warn us. The Atlas Network, Asteroid Terrestrial Impact Last Alert System, was built to find killers in the dark, the small and silent ones that could end our story without even meaning to. That night, it found something else. The software marked it as insignificant. A speck, a false alarm, perhaps a pixel corrupted by cosmic rays. But then, in the next frame, it moved. Not the way satellites move in steady, predictable lines. Not the way debris drifts. It moved with intention, or what looked like it. The coordinates shifted just enough to make the human brain lean forward. And once a human begins to lean toward the unknown, the world is no longer quiet. Dr. Elena Voss was the first to notice. She had seen thousands of false trails, thousands of phantom streaks in the sky, but this one felt different. The movement was too clean, the speed too great. She watched the data scroll across her monitor, the numbers describing a path that no object in our solar family should take. She called in a colleague, then another. Within an hour, 5 screens glowed in the dim control room. 5 minds orbiting a single question. What is that? Outside, the air over the Atacama Desert was thin and clear, the kind of stillness that humbles even machines. The telescope continued to sweep, gathering photons that had traveled for decades through vacuum, each one a fragment of a message no one had written. The computers whispered through the night, translating light into meaning. At 0213 UTC, the anomaly confirmed itself. Not a glitch, not a ghost. An object, real and measurable, moving on a trajectory that sliced through the plane of the solar system at an impossible angle. The software calculated a velocity over 200,000 kilometers per hour. Elena blinked, then recalculated. The numbers did not change. Hyperbolic, someone said softly, as if speaking too loudly might break the data. Another voice answered, "Then it's not from here." That single sentence spread through the network like fire through dry grass. Emails, pings, encrypted channels, observatory to observatory, hemisphere to hemisphere. The message carried no poetry, only coordinates and timestamps, but those numbers sang. Within hours, telescopes from Hawaii to the Canary Islands were turning, chasing the ghost that refused to stay still. For the first time, since Oumuamua, humanity felt the shiver of being observed by its own curiosity. The universe had sent us another note, and this time it arrived with a tale. By dawn, the first composite image had formed, a faint smudge of light, barely distinguishable from the cosmic static. To the untrained eye, it was nothing. But to those who had spent their lives staring into infinity, it was everything. The smudge was alive. It was breathing, releasing gases even as it crossed into the sun's domain. Something ancient was waking up under our light. Scientists argued quietly through the morning. Was it a comet? Was it an asteroid? Was it both or neither? Its orbit made no sense. Its path was too steep, its speed too pure. The equations that described it refused to settle into anything familiar. And then came the realization that froze every conversation in the room. The object was not bound to the sun. Its path was open-ended, a curve that entered and would one day leave again. It was passing through, like a stranger cutting across a field we thought was ours alone. 3I Atlas. That was the name they gave it, the third interstellar object ever found. Third, but not ordinary, because where Oumuamua was silent and rocky, and Borisov was icy and swift, this one seemed almost defiant. It behaved as if it had its own set of laws. By the evening news cycle, the story had reached the public. Headlines spoke of a cosmic visitor, of another messenger from beyond. Television graphics showed glowing paths through digital star fields. Most viewers saw it as a curiosity, a brief headline before sleep. But those who understood orbital mechanics could not look away. The numbers told a truth that no animation could capture. This was a traveler from outside every boundary we knew. In quiet laboratories, astronomers ran simulations, each one more absurd than the last. They traced its route backward through interstellar space, each time losing it in a fog of gravitational uncertainties. It had come from nowhere we could name. Every model led to emptiness. Somewhere between awe and fear, a thought began to take shape. If one visitor has come, and another, and now a third, how many more are crossing silently, unseen, through the dark corridors of our solar system? The Atlas network continued to track it night after night, feeding data to supercomputers that strained to predict its future. The trajectory curved closer to the sun. Not dangerously close, but close enough to wake its frozen chemicals. The first faint signs of activity appeared: outgassing, a coma, the breath of a world that had slept in interstellar winter for eons. 3I Atlas was alive. Not in the way we are alive, but alive as only a comet can be. An engine of vapor and ice, heat and silence, memory and momentum. A remnant of some other genesis, now unraveling in our light. Elena watched the new data come in and felt something ancient stir inside her, a blend of terror and privilege. She whispered to herself, "We're not supposed to see this." But she kept watching anyway, because that's what humans do when faced with the abyss. We look. Out there, the object moved, indifferent to our wonder. It did not know it was being named, or measured, or feared. It was only obeying gravity, the oldest commandment in existence. And yet, to those who watched, it felt like something more. A pulse in the cosmic dark. A spark that had traveled too far to be ignored. The spark in the dark had become a sign. And for the first time in years, the universe was whispering again. By the time the object received its official designation, 3I Atlas, the world's astronomical community was already divided between two instincts: to classify and to wonder. Because in that small prefix, 3I, lay a story larger than numbers, the story of pattern. The first was Oumuamua, discovered in 2017, a silent shard, long and thin, tumbling through space like a piece of broken machinery. It never grew a tail. It reflected light like polished metal. It spun too fast, too precisely. The second, 2I's Borisov, came 2 years later, a more familiar messenger, icy and bright, a comet in every way except its birthplace. It moved like something with memory. And now, the third, 3I Atlas, a triad, a rhythm, a whisper repeating itself through the dark. One visitor can be coincidence. 2, curiosity. 3, a pattern. That realization changed everything. For the first time, scientists had to face a new truth. Interstellar objects were not rare miracles, they were inevitable. The void between stars was not empty, but alive with travelers, drifting fragments of creation, crossing the interstellar gulf like silent ships. Each one a message, each one proof that we are not isolated even in emptiness. And yet, for all that knowledge, the feeling beneath it was not comfort. It was unease. In the early days of tracking 3I Atlas, astronomers spoke in restrained voices, like surgeons describing a patient they didn't fully understand. Every orbit plotted, every parameter refined, made it stranger. Its incoming trajectory came from a region of space nearly perpendicular to the ecliptic, the flat, disk-like plane where all the planets orbit the Sun. Nothing from our system moves like that. Its speed, too high to belong. Its path, too clean to have been captured by any nearby star before ours. 3I Atlas was not visiting by accident. It was passing through as though the solar system were nothing but a shadow on its way. Across observatories and online forums, the tone of discussion shifted. First came fascination, then calculation, then something that felt eerily like superstition. Some whispered about the Trinity of Wanderers. Others half-joked about omens. Most simply stared at the data, knowing it wasn't magic, and feeling that it might as well be. At NASA's Jet Propulsion Laboratory, a small team of orbital analysts spent 3 sleepless nights recalculating 3I's trajectory. By the end of the third night, they confirmed what Atlas had already shown. It would pass safely, roughly 1.4 astronomical units from the Sun, near the orbit of Mars, before vanishing back into interstellar night. No threat, no collision, just a visitor. Yet no one truly felt safe. Because the numbers didn't quiet the deeper question that had begun to pulse behind every equation. Why now? The first interstellar object had arrived in 2017, the second in 2019, the third in 2025, the gaps between them shrinking, coincidence or rhythm. If cosmic time were a heartbeat, it was speeding up, and though reason told them this was mere statistics, emotion told another story, that the universe was beginning to pay attention. In the archives of the International Astronomical Union, the formal record was dry and clinical. 3I Atlas, third confirmed interstellar object, first observed July 1, 2025, by the Atlas Survey Telescope at Rio Hurtado, Chile. But that sterile entry could not capture what it meant to those who watched the faint image on their screens. For scientists like Elena Voss, the name 3I felt almost mythological, a mark of continuity, the third stanza in a poem written across light years. She remembered Oumuamua as a whisper of technology, Borisov as a promise of familiarity, and now Atlas as something else entirely. It wasn't just the object's behavior that unsettled her, it was the implication of scale. If 3 had already crossed our skies in less than a decade, how many more had passed unseen through the void? How many were out there now, invisible, silent, eternal? When she presented the first full analysis to her team, she ended her talk with a single unscientific sentence. We are standing on the edge of a galactic tide, and it's starting to rise. The media, as always, took what it could. Headlines flashed. Another interstellar visitor detected. News anchors smiled as holographic comets blazed across studio screens. It was easy to sell awe. It was harder to sell unease. Most viewers changed the channel before the closing credits, but a few did not. A few stared at the glowing images of that distant traveler and felt something ancient stir. The same feeling our ancestors must have known when they first looked up and saw comets blazing above their villages. Fear, awe, and the unspoken thought, perhaps we are not alone after all. Meanwhile, deep within scientific circles, another kind of tension brewed. Data from multiple observatories began to suggest that 3I Atlas was releasing gases earlier than expected. long before reaching the sun's warmth. This was unprecedented. Most comets wake only when they approach the inner system. But Atlas was already breathing in the dark. One theory proposed that it carried exotic ices, carbon dioxide, nitrogen compounds, or other volatiles that sublimated at far lower temperatures than water. Another suggested something stranger, that long exposure to interstellar radiation had changed the chemical bonds themselves, turning ordinary materials into ghostly, unstable forms that now screamed back into vapor when touched by sunlight. Every model brought more questions. Every answer dissolved into more silence. And through it all, the object moved on, indifferent, unstoppable, mathematical. By late August, 3I Atlas had entered the domain of our inner planets. It was faintly visible to large telescopes, its coma glowing a spectral green, a color that cameras exaggerated but still existed, haunting and real. To the public, it was beautiful. To scientists, it was terrifying. Because green light meant molecular carbon, C2, a fragile compound that burns into existence only when a comet's gases are violently stripped by solar radiation. It meant activity, volatility, unpredictability. It meant life, of a kind. In a quiet conference room at the European Southern Observatory, an older astronomer looked at the spectral data and said almost to himself, "We call them visitors, but maybe we're the ones being visited." No one answered him. Outside, the desert wind moved softly around the domes. Above them, the third visitor crossed the black between stars, and for a moment, just a moment, it felt like the universe was watching back. When the first solid stream of numbers arrived, they came in silence, rows of decimals and coordinates, time-stamped, unfeeling. But behind those numbers, the air in the control rooms began to change. Data has a rhythm, a texture. To those who live by it, anomalies sound like dissonance in a familiar song. The measurements of 3I Atlas didn't just sing off key, they hummed from an entirely different scale. Each observation tightened the curve of its orbit, but the curve refused to close. Each velocity check refined the model, but the velocity grew more absurd. Every time the algorithms adjusted the parameters, they found themselves chasing a ghost. By the end of the first week, the conclusion was impossible to ignore. This object would not stay. It wasn't looping around the sun. It wasn't visiting to linger. It was passing through, a hyperbolic flyby, bound for nowhere we could name. The sheer speed, over 200,000 kilometers per hour, tore apart the last doubts. No asteroid, born in the quiet nursery of the solar system, could travel that fast without being flung into ruin. This was not our child. It was a wanderer, a thing born elsewhere, older and colder than the planets we called home. At the Minor Planet Center, calculations poured in from observatories across the globe. Hawaii, Chile, South Africa, Australia, all eyes pointed toward the same green whisper moving against the stars. The more data they gathered, the stranger the story became. Its brightness fluctuated in erratic rhythms, like the pulse of a dying star. At times, it dimmed for hours, then flared without reason. Some suspected rotation, others outgassing, still others something they dared not publish yet. Spectroscopy brought its own puzzle. Carbon dioxide? Yes. Carbon monoxide? yes, but far less water than expected. A dry comet, a paradox. In the cold vacuum between stars, water ice should have survived. So what had burned it away? One theory suggested a violent ejection, that 3I Atlas had once belonged to a young, unstable system thrown into exile by a giant planet's gravity. If so, it may have wandered through radiation storms for millions of years, its ices altered, its chemistry scarred. The numbers hinted at that. Fragments of spectra like fingerprints from a burned world. Still, the data refused to form a full picture. It was as if the object had learned to hide its history. Every measurement revealed a truth that unmade another. Dr. Elena Voss barely slept. Her days turned into a cycle of recalculations and quiet astonishment. She and her team at the Cerro Tololo Observatory were among the first to detect the faint rise in brightness, a sign of activation. The comet was waking up, but not where it should have. Usually, comets begin to exhale gases when they cross the frost line, around 3 astronomical units from the sun, where heat can sublimate the frozen materials. But 3I Atlas had already begun venting carbon dioxide at nearly twice that distance. That meant its surface was far more volatile, or that it had never truly been asleep at all. In the dim control room, she stared at the spectra again. Each spike of green and violet represented a molecule singing in sunlight, a signature of matter long alien to our system. And though her mind processed the chemistry, a deeper part of her, the ancient human part, felt something closer to dread, because it wasn't just what the data said, it was what it implied, that interstellar space was not a void of silence, but a crucible where things could live, change, endure, that between the stars there were places so cold and old that matter itself learned to dream differently. By the third week, the object had gained a voice. Not in sound, but in light, a spectrum that spoke through every observatory that watched. It glowed green, the color of carbon and strangeness, visible even through the interference of the lunar glare. News sites began publishing photographs, a ghostly smudge with a long emerald tail curling like smoke across the cosmos. The public called it beautiful. Astronomers called it a mystery. Elena called it something else, a signal. She wrote in her notes, 3I Atlas is more active than it has any right to be. If Oumuamua was a whisper and Borisov was a song, this one is a call. We should be careful what we answer. Soon, the first global conference convened, a hybrid meeting spanning time zones and languages. A mosaic of faces appeared on screens, physicists, chemists, orbital modelers, all staring at the same luminous smudge from 1,000,000 kilometers away. Charts filled the displays, lines of color and error bars, predictions of brightness, trajectories. But under the numbers, everyone felt it, the growing sense that the familiar universe was cracking and something vast was shining through. Dr. Hiroshi Takeda from Tokyo pointed to the velocity data. Look at this pattern, he said. Its speed before perihelion doesn't drop as expected. It's losing less kinetic energy than models predict. Someone countered, then our models are wrong. Another murmured, or it's made of something that doesn't behave like our ice. The discussion spiraled between math and myth until Elena spoke. Her voice was quiet, but steady. It's not impossible. It's just unfamiliar. That's what the word interstellar means. It's not that it breaks the rules. It comes from a place where the rules are written differently. A pause followed, heavy as the void itself. Outside, in the real sky, 3I Atlas continued its journey, utterly indifferent to the minds dissecting it. It drifted inward, leaving a wake of invisible dust and gas. Particles from a star system we would never see were now mingling with the breath of our own. A microscopic handshake between worlds. In one frame, captured by the Gemini North Telescope, the comet appeared almost alive, a green head with a filament tail, twisting like smoke in the solar wind. The scientists saw turbulence. The poets saw a serpent in flight. Both were right. As the data mounted, a phrase began to echo in every research center. We're looking at a traveler from another sun. For most, it was thrilling. For a few, it was terrifying. Because to see one traveler is to imagine countless others, drifting unseen, carrying with them fragments of alien worlds, bits of lost histories, pieces of origins that predate us all. And deep down, in the quiet between calculations, even the most rational scientists could feel it. The sense that maybe, just maybe, the universe had started looking back. Before 3I Atlas, there were two others. Two warnings written in light. The first came quietly, almost unnoticed. October 2017. A small telescope in Hawaii caught a line of motion where none should be, a cigar-shaped body hurtling through the inner solar system at 87 kilometers per second. It was Oumuamua, the first confirmed interstellar object ever seen by human eyes. Its name, from Hawaiian, meant a messenger from afar arriving first. A name born of wonder and denial. Oumuamua changed everything. It didn't behave like a comet, didn't shine like an asteroid. It showed no visible outgassing, yet it accelerated, as if pushed by invisible pressure. Theories multiplied like shadows. Maybe it was made of hydrogen ice. Maybe it was a fragment of a shattered planet. Maybe, in the most daring whispers, it was something constructed, a derelict from another civilization. The world laughed, argued, then forgot, because it left too quickly. By the time we aimed our instruments, it was already fading into darkness, a ghost on the edge of memory. We told ourselves it was a curiosity, a one-time visitor. But the universe does not do one time. 2 years later, in 2019, the second arrived. 2I Borisov. This one was easier to understand, easier to love. A true comet, bright and breathing, its icy tail unfurled in sunlight like a flag from another world. Discovered by an amateur astronomer, Gennady Borisov, it became a global spectacle. It carried the scent of familiarity, cyanide, carbon monoxide, dust. It behaved like something from home, even if home was light years away. But buried in its chemistry was the same unsettling note. Its ices were richer in carbon and poorer in water than any comet we'd seen. It was built in a colder, harsher nursery, a place where stars burned faint and long, where life might never have dared to wake. When Borisov disintegrated near perihelion, its fragments drifted through our system, microscopic relics from another sun, dissolving into our cosmic dust. And now, 3I Atlas, not an isolated miracle, not an echo, but a continuation. The pattern complete: rock, ice, and something between. Elena Voss stared at their trajectories side by side, three elegant hyperbolas arcing through digital blackness, three signatures of alien birth. Oumuamua, thin, fast, silent. Borisov, bright, classic, doomed. Atlas, green, volatile, unpredictable. Each one had entered from a different direction, like messengers converging from the corners of the galaxy, and each one had left behind more questions than answers. What were the odds? Three interstellar travelers within less than a decade, after billions of years of silence. Astronomers ran the numbers, shrugging at the impossible. But probability is a fragile comfort when the cosmos begins to look deliberate. Somewhere in the archives of the European Space Agency, a note appeared in a meeting transcript. We are beginning to detect the interstellar background, not stars, but debris. The Milky Way is breathing, and we're starting to hear it. The echoes of the first two visitors shaped every observation of the third. Oumuamua had taught scientists humility, how quickly the unknown can vanish beyond reach. It reminded us that cosmic discovery has no mercy for hesitation. For weeks after its departure, astronomers spoke of frustration in hushed voices, a once-in-history opportunity gone. Borisov had taught us nostalgia, that even across light years, creation obeys familiar laws, that we are not unique even in chemistry. We found comfort in that, briefly. But 3I Atlas, it taught something colder, that perhaps the universe was not merely sending echoes. Perhaps it was speaking in a new language, and we were only now learning to hear the grammar. At the International Center for Astrophysics in Geneva, a presentation compared their compositions. Slides flickered, molecular charts, carbon ratios, infrared spectra. On the surface, it was science. Beneath it, something close to dread. Because a pattern was forming in the data, faint but insistent. Each new visitor carried slightly higher levels of complex carbon compounds, each one more chemically alive than the last. Is this evolution? One researcher asked. Or coincidence? No one answered. The silence was long enough to be uncomfortable. Elena finally spoke, her voice calm, but her eyes bright. Maybe it's not evolution. Maybe it's a gradient. We are sitting inside a galaxy that is stirring itself, mixing old systems with new. These travelers are not random. They're the breath of the galaxy itself. The room was quiet, not because it was poetry, but because it was possible. In public, they kept their language cautious. Unusual chemistry, interstellar characteristics, early activation. But behind the walls of data centers, a different kind of conversation bloomed, one that drifted between science and myth. Some spoke of the Great Exchange, the idea that interstellar objects carry matter from one system to another, scattering seeds of carbon and organic dust, connecting planets that will never meet. Others leaned toward the poetic, calling them letters between stars, fragments of cosmic autobiography. And in quiet, private corners of the internet, a darker theory circulated that these objects were not wanderers at all, but wreckage, ruins of ancient catastrophes, broken worlds flung into eternal exile, their pieces now crossing our sky as faint green warnings. When 3I Atlas was photographed in mid-September, its tail long, luminous, curved like a question mark, an old journalist asked on live broadcast, How many times must the universe knock before we answer? No one could say. In classrooms, children drew comets and colored them green. In labs, scientists stayed awake until dawn, passing the uncooperative data. In dark fields, ordinary people pointed cameras at the heavens, tracing the faint smear that was not a star. And all across the planet, in places where humans had forgotten to look up, something in the collective subconscious stirred again. That ancient instinct, older than language, older than faith, the one that whispers, "The sky is moving." 3 visitors, 3 signs, 3 memories of stars not our own. And somewhere, far beyond the reach of our telescopes, countless others drifted unseen, waiting for their turn to be noticed, or perhaps to notice us. In the weeks that followed, the discovery of 3I Atlas spread through the world like a weather front. Slow, invisible, inevitable. It began in whispers among scientists and ended in the thunder of headlines. Every observatory, every telescope, every amateur sky watcher was suddenly looking in the same direction. And the more they looked, the stranger the story became. For the first time in years, space was no longer an abstraction. It wasn't the calm ocean of distant stars we watched from the safety of our screens. It was alive. It was moving. It was coming closer. On the second week of August, international agencies released the first public orbital projections, a swirl of lines and numbers overlaid on a map of the solar system, clean, clinical, meaningless to most. But somewhere inside, that geometry was a simple truth. The visitor was inbound. It would pass within the realm of the inner planets, close enough to study, close enough to see. Newspapers called it the ghost with a green heart. Headlines competed for metaphor: alien ice ball, messenger from the void, the comet that shouldn't exist. Television shows dramatized its trajectory. Animated suns flared, planets revolved, digital tales burned across blue screens. And behind all the spectacle, a quieter current of unease spread. The sense that something about this arrival was different. Not dangerous, not yet, just too precise. In research centers from Arizona to Zurich, sleepless teams ran models. Each day they refined the orbit, feeding the data into newer algorithms, more powerful computers. Each result confirmed the same impossible harmony. The path was clean, uninterrupted, and strangely stable, as if plotted with intent. One researcher joked darkly, "It flies like it's avoiding something." No one laughed. The public fascination became obsession. YouTube filled with amateur theories. TikTok turned its green shimmer into a meme, the ghost star. Religious groups began preaching about the third sign. Astrologers claimed ancient texts had foretold it. And in the background of all this noise, the real scientists worked in silence, surrounded by data that grew heavier with every night of observation. Governments, too, began to pay attention. Not out of wonder, but of calculation. Anything moving that fast, that bright, demanded analysis. Could it fragment? Could it interact with Earth's orbit? Could it carry material that might reach our atmosphere? The official reports were calm, a model of bureaucratic serenity. But the classified memos were different. Behind closed doors, the tone was sharper, the words more human. Trajectory stable, but composition unknown. Object highly volatile. Possible dust stream intersection with Earth's orbital plane in late 2026. Small words, big consequences, the kind that make generals and ministers stare at the ceiling longer than usual. In homes around the planet, the phenomenon seeped into dreams. People who had never cared about astronomy began to check the sky at night. They couldn't see it, not yet, not with their eyes, but they wanted to. The idea of something coming from beyond made the familiar stars look fragile. The sky, once comforting, became a mirror that reflected our ignorance back at us. Poets wrote about it. Musicians sampled telescope data into songs. Influencers sold necklaces shaped like hyperbolas. And still it came, slowly, steadily, unchanging. Every culture found its own name for it. In Japan, it was Koko no Hoshi, the passing star. In Russia, Ghost is, to me, the guest from the dark. In the West, it remained what the scientists had called it. 3I Atlas, a code that sounded sterile, but in that sterility hid awe, the kind only numbers can hold. By late September, the object had brightened enough for mid-sized telescopes to glimpse its glow. Photos began appearing online, a faint emerald smudge on the edge of infinity. Each image sharpened the world's fixation. Even those who didn't believe in omens could feel the unease of coincidence. 3 interstellar visitors, each more visible than the last, each arriving faster. Patterns have a way of making people nervous. Elena Voss sat in her lab at Cerro Tololo, watching the latest frame load pixel by pixel. Her monitor displayed a swirl of green, the faint tail bending away from the sun. The object was alive now, venting gas, changing form. It reminded her of a breathing lung, expanding and contracting in cosmic rhythm. She whispered, "It's adapting." Her assistant looked at her, puzzled. Adapting to what? Elena didn't answer, because deep down she didn't know. The storm grew not in the heavens, but in human minds. Philosophers spoke of perspective, of how small we were. Economists spoke of opportunity, how every new discovery meant funding. Religious leaders spoke of signs, of cleansing and rebirth. And yet, beneath all the words ran the same pulse, ancient and instinctive, the animal knowledge that something unknown had entered our territory. Somewhere, a student built a model in her dorm room, projecting the comet's speed and direction. She stared at the path and felt a strange mix of fear and wonder, as if she were tracing the outline of a secret too vast to keep. She uploaded her animation to social media. By morning, it had 1 million views. By evening, 10 million. The caption read, "It's not coming for us, but it's coming through us." In one of her late-night recordings, Eleanor wrote, "It feels like we've invited the sky to speak, and now we can't turn it off." The first visitor was a question. The second, an answer. The third feels like the beginning of a conversation. Outside, the desert wind carried dust across the domes of the observatories. The telescopes kept turning, their great mirrors drinking starlight like ancient eyes. The air was dry, the silence total, the stars unblinking. And somewhere beyond Mars, a green spark was threading its way toward the heart of our system. Not with menace, not with mercy, but with the indifference of the infinite. The storm was not in space. It was here, in the fragile rhythm of human thought, in the trembling understanding that for the first time in history, we were no longer the only travelers in the dark. By October, the world had stopped asking when it would arrive. The trajectory was known, the numbers precise. The object's path was locked. It would sweep past the sun, curve gently through the inner system, and then vanish forever into the galactic night. There would be no collision, no disaster, no spectacle beyond the reach of telescopes. And yet the fear did not fade, because what remained was worse than danger. What remained was the question. At every level of human society, from research labs to midnight podcasts, the same conversation echoed. What is it? Not its orbit, not its mass. Those were solved, but its meaning. The thing it represented simply by existing. In a room full of mathematicians, someone asked, "Why does it glow green so far from the sun?" A chemist answered, "CO2 and C2 activation, nothing mystical." A physicist added, "Radiation processes, normal." But the word normal lingered like irony. Nothing about 3I Atlas felt normal. It was behaving like something that wanted to be seen. Outside, the desert night hummed with insects, and the stars hung indifferent above the domes. Inside, the hum of the computers sounded like breathing. When Oumuamua came, people had whispered, "Maybe it's a ship." When Borisov came, they said, "It's a comet, nothing more." But now, with Atlas, the whisper changed. It wasn't about what it was. It was about why it came at all. There was a time when humanity believed in divine comets, swords of fire, warnings of kings' deaths, harbingers of change. We have outgrown that mythology, or so we say. Yet as the green wanderer crossed our skies, every culture seemed to revive its oldest reflexes. Temples lit candles. Scientists stayed awake. People who hadn't looked up in years stepped outside and stared. No one believed in omens anymore, but everyone acted as if they did. Because deep down, the unknown still speaks the same language. And that language is fear. In early October, the object passed the orbit of Mars. It was now close enough that even modest telescopes could capture it, a faint, luminous tear in the night. The data confirmed what some had already guessed. Its composition didn't match anything we had catalogued. Ratios of isotopes, carbon-13 to carbon-12, off by measurable degrees. Traces of molecular chains that shouldn't exist in stable form. Chemistry not impossible, but alien in its balance. It was, by every metric, a visitor from elsewhere. And that elsewhere, that word, was heavier than any equation. Elena Voss sat in her lab long after midnight, staring at a simulation looping endlessly across the screen. It showed 3I Atlas sweeping past the sun, glowing, turning, fading, gone. A perfect arc, predictable, meaningless, and yet her mind refused to accept it. "What if the meaning isn't in the path," she whispered, "but in the fact that there is a path?" Her colleague, half asleep, murmured, "You mean it's following something?" She nodded, "Or being followed." No one spoke after that. Every discovery in history begins with data and ends with a question. This one was no different. But the question that 3I Atlas posed wasn't about composition or motion. It was about reflection. What do we see when the universe sends something from beyond our cradle? Do we see science, or do we see ourselves? Humanity, for all its precision, is still a species of myths. We have simply traded the language of gods for the syntax of numbers, but our awe is the same. We name comets, chart their paths, give them designations, not because we understand them, but because naming is the first defense against the infinite. And still, the infinite doesn't blink. As October bled into November, the object brightened further. Its coma expanded, glowing emerald against the black. The media called it the Eye of the Galaxy. The nickname spread faster than any scientific paper. And suddenly it had personality. The world spoke of it as if it were alive. It's waking up. It's watching. It's remembering. Human words for inhuman behavior. Projection, maybe, or instinct. Late one night, Eleanor dictated her final notes for the week. It's strange how we anthropomorphize the unknown. We can't bear the thought that the universe acts without intention. We keep asking who sent it, as if the void owes us a message. Maybe it's not a messenger at all. Maybe it's a mirror. By mid-November, 3I Atlas crossed its perihelion, its closest approach to the sun. For a few brief hours, its brightness surged, its tail lengthened, and then, slowly, it began to fade. The astronomers watched in silence. The cameras clicked. The numbers flowed. Nothing extraordinary happened. No fragments broke off. No explosions. No deviations. Just a clean exit into forever. And yet, those who watched could not shake the feeling that something had happened, something unquantifiable, as if the moment itself had been watching them back. In a broadcast interview, a journalist asked Eleanor a final question. "Dr. Voss, after everything we've seen, what do you think it is?" She hesitated. All the language of science, all of the safety of uncertainty, collapsed under the weight of the simplest truth. "It's a question," she said softly. "That's what it is. A question the universe is asking us." The interviewer frowned. "And what question is that?" Elena smiled faintly, her eyes tired but alive. "Whether we're ready to listen." Far beyond Earth, 3I Atlas continued on its silent course. No eyes could follow it now. Its green glow dimmed to gray, then to nothing. The dust it shed dispersed across the Black Sea between worlds, a trail of forgotten atoms, a whisper left behind. Somewhere, light from the sun caught that dust for a final moment, scattering it like sparks through the dark. And in that instant, a fragment of our solar wind brushed against matter that had once known another sky. Two systems touched, two stories crossed, and both continued, unaware. The visitor was gone. The question remained. And on a small planet, orbiting a quiet star, billions of minds turned upward, not because they feared what was coming, but because for the first time they feared what might be waiting to follow. Anatomy of an interstellar comet. If Act 1 was the story of discovery, Act 2 is the story of dissection. Now that humanity had seen the traveler, it began to take it apart, photon by photon, pixel by pixel. And in the glare of the data, something both intimate and terrifying emerged, the shape of a stranger. At first, 3I Atlas seemed almost shapeless, a smear of light, soft and inconsistent, changing with each night's observation. But once enough frames were gathered, once the images were cleaned of noise and artifacts, the shape began to whisper through the data. Not a sphere, not an ellipsoid, something ragged, something fractured, like a sculpture eroded by time itself. Radar could not reach it. The object was too distant, too fast. So astronomers relied on the oldest method in the universe, light. Every glimmer, reflected from its surface, told a story about its geometry. And the story was strange. The light curve, that subtle flicker in brightness as it rotated, suggested a rotation period of just under 15 hours. But the amplitude of that curve, the difference between bright and dim phases, was enormous. That meant elongation. It wasn't a compact world. It was long, uneven, tumbling. Some called it the shard, others the relic. Elena Voss, in her notes, wrote simply, "It looks broken. Broken, but beautiful." As it neared the sun, sunlight caught the fractured surfaces, and the object began to shimmer with an impossible palette. Spectrometers recorded reflected wavelengths shifting in subtle ways, pale green, bluish-white, then almost golden near the edges of its coma. These were not true colors, not as the human eye would see them. They were spectroscopic moods, the fingerprints of molecules dancing under radiation. C2 molecules, carbon dimers, ignited under ultraviolet light, releasing that ghostly green fluorescence. CO2, heated into vapor, refracted faint blues along the jetting plumes. Mixed with dust, the entire body took on a soft luminescence, like a dying ember refusing to go dark. The shape, though, remained uncertain. Every new measurement contradicted the last. One model suggested a cluster of fragments held together by gravity. Another proposed a single nucleus, 15 kilometers wide, but irregular, dented by cosmic erosion. Each theory was a story written in the language of light, none entirely true. As Elena put it, we are describing a face we can only see through its reflection. The comet's brightness didn't behave as expected. Normally, comets follow predictable light curves. They brighten steadily as they near the sun, then fade symmetrically afterward. But 3I Atlas refused symmetry. Its rise was abrupt, erratic, almost violent. Then, instead of peaking at perihelion, it dimmed, as though trying to disappear the closer it came. Some suspected the cause was geometry, that its rotation exposed volatile regions in irregular bursts. Others whispered about composition, strange alien minerals absorbing sunlight differently. A few simply called it the behavior of the unknown. And for every theory, there was a pause. The unspoken awareness that we were not just studying physics, but a fossil of another sun. An object born around a star that might not even exist anymore. By late November, computer renderings had begun to circulate, visualizations based on the evolving data. They showed a long, asymmetrical core, wrapped in a cloud of glowing vapor, jets spiraling from its surface like threads of silk. It rotated in silence, a drifting cathedral of ice and dust. The scientists called it non-principal axis rotation, chaotic tumbling. The poets called it grace. The more we learned about its motion, the more it resembled memory, a slow, disoriented dance, as if it were remembering how to fall. Each spin, each flicker, each flare of light, the echo of collisions that had sculpted it in some ancient, invisible place. The analysis teams at Gemini and JWST began to estimate its mass, somewhere between 1013 and 1014 kilograms, vast but still fragile. Its density suggested porosity. It was not solid, but woven, full of voids and hollows, a sponge of frozen history. Elena once said in an interview, "When you look at 3I Atlas, you realize that everything solid is an illusion. Even stone remembers being dust." The strange brightness pattern persisted, forcing a redefinition of its surface properties. Some areas, the data implied, were unusually reflective, almost metallic. Others were pitch black, absorbing nearly all light. A patchwork of contrasts, bright scars against darkness, like a body stitched together from worlds long gone. The team began to wonder, could some of those bright patches be crystalline ices exposed by impact? Or could they be something more exotic, solidified hydrocarbons, long polymerized by radiation over millions of years? Each possibility felt more alien than the last. Whatever it was ancient, a billion-year-old archive written in frozen atoms. One theorist from Caltech described it best. Imagine a fossil, but instead of bones, it's made of the chemistry of another solar system. We are looking at the remains of someone else's beginning. As December approached, 3I Atlas began its slow retreat from the sun. Its coma thinned, its brightness faltered, but its mystery deepened. The instruments still recorded intermittent bursts of gas, like sighs, irregular and fading. Perhaps fractures had opened on its surface, venting the last breaths of its volatile heart. Perhaps something within it had cracked for the final time. Whatever its truth, the shape of the stranger was now known. Not precisely, not completely, but enough. Enough to know it was not round, not orderly, not serene. It was scarred, unstable, fractured, a monument to violence and endurance. And in that brokenness lay its beauty. In her final note of the year, Eleanor wrote, "We build our worlds to last. The universe builds hers to travel. 3I Atlas is not a visitor, it's a survivor." What we call fragility might simply be the form of resilience at interstellar scale. The shape and the shine of the traveler, jagged, radiant, imperfect, reminded everyone of a truth older than stars, that even in the coldest dark, there is still light enough to remember where you've been. It began with a hiss, not a sound, of course. Space has no air to carry it, but in the data, it was unmistakable. The slow exhalation of something waking from an impossibly long sleep. The first spectroscopic readings showed traces of carbon dioxide, faint but persistent, streaming from 3I Atlas long before it reached the sun's warmth. It was a kind of chemical whisper, and for those who listened, it carried a single, disquieting truth. This thing was alive far too early. In most comets, the dance begins near the frost line, around 3 astronomical units from the sun, where water ice finally warms enough to sublimate. The sequence is orderly, predictable. First, CO2 and CO wake, faint and thin. Then, closer to the sun, water joins the chorus, driving the grand outburst that paints the sky with tails. It's a script the cosmos rarely deviates from. But 3I Atlas had never read our script. At nearly 6 astronomical units farther than Jupiter, it was already exhaling carbon dioxide in torrents. Its coma, the glowing shroud of vapor and dust, expanded in defiance of temperature. The comet was breathing in the cold, and no one could say why. The first reaction among scientists was disbelief. Elena Voss herself, double-checked the calibration of every sensor. They weren't wrong. The emissions were real, intense, rhythmic, pulsing like a slow heartbeat. Each pulse coincided with the object's rotation, suggesting jets bursting from specific regions on its surface. Localized vents, controlled eruptions, a choreography of chemistry. It was as if 3I Atlas carried reservoirs beneath its crust, pockets of CO2 trapped for eons, now cracking open in a frozen exhalation. But that didn't explain why it happened so far from the sun. Something inside it was volatile in a way no comet from our system ever was. One researcher compared it to a wound reopening in zero gravity. Another said quietly, maybe it doesn't need heat to remember it's alive. Carbon dioxide, a simple molecule, two oxygens hugging a single carbon, and yet, in this context, it became an alien signature. The ratios were wrong. Far too high compared to water, far too steady compared to CO. It hinted at a place of origin colder, darker, and older than any we had imagined, a region where CO2 ice formed not as frost, but as bedrock. Spectral analysis painted a portrait of chemical purity, an environment unpolluted by heavy metals, rich in carbon and nitrogen compounds. Perhaps a dim red dwarf system, or the edge of a dying nebula, where temperatures linger near absolute zero. Whatever its birthplace, 3I Atlas carried that memory like lungs carry air, invisible but vital. The data was poetry written in gas, and every new reading added a line to a growing alien verse. By December, the comet's breath became unpredictable. Jets appeared and vanished, some erupting from the night side, others from shadowed craters. The outgassing wasn't uniform. It was intelligent in its chaos, complex enough to feel deliberate. Not sentient, but patterned, as if responding to forces we didn't yet understand. Computer simulations tried to map the vents, assigning them coordinates, labeling them with sterile precision. But every model eventually collapsed under its own contradictions. The pattern shifted too quickly. It was like trying to chart the wind of another planet. At an emergency symposium, Eleanor addressed a crowd of weary scientists. We're observing thermal reactions beyond our temperature models. The only consistent factor is carbon dioxide. It dominates the entire emissions spectrum. If it were water, we could blame the sun. But this... She paused, searching for the right words. This is something older than sunlight. The room fell silent. Outside, in the desert, the real wind moved around the domes like an echo of her words. Every comet exhales its history. In the vapor, you can read its formation, its childhood, its exile. With 3I Atlas, those vapors spoke of a world that might never have known warmth at all. A cradle lit by distant starlight, its chemistry frozen before time began. Elena's team began calling it the breath of the dead star. Unofficially, of course, but the name spread quietly through the scientific underground. It fit too well. The ratios of CO2 to H2O were unlike anything in our catalogue, almost inverted. If water was life, this comet was its reflection. A mirror of everything familiar, inverted and cold. As it approached the sun, astronomers expected the CO2 emissions to fade, replaced by the brighter, more powerful signature of water vapor. But that never happened. Instead, The carbon dioxide grew stronger. The comet's breath thickened, its coma expanded, and the green luminescence deepened like the glow of phosphorescent skin. For a few brief days, the solar wind caught that vapor and twisted it into spirals, long ribbons of carbon breath stretching across millions of kilometers. Images from the Gemini telescope showed the tail splitting into two, one dust, one gas, each glowing with different intensity, each following its own physics. It was beautiful and wrong. In interviews, Eleanor's voice trembled when she tried to explain. We've always assumed the sun dictates when comets awaken, but 3I Atlas behaves as if it remembers its own light. It's self-igniting, like it carries its own sun inside. Later, when the object began to drift back into darkness, the CO2 emissions slowly waned. But their rhythm, that faint pulse that had haunted the data from the beginning, never vanished entirely. Even as it receded beyond Mars, the breath persisted. Weaker, yes, but steady, like the fading heartbeat of something that refused to die. Some said it was simply residual sublimation. Others thought it might be internal heating from radioactive decay, an echo of the isotopes born in another system's collapse. But there was one final theory, whispered among a handful of researchers, unpublishable yet impossible to ignore. Maybe this is how interstellar comets navigate, not with intention, but with memory, breathing themselves toward warmth wherever they go. The last observation came from the James Webb Space Telescope, far beyond Earth's atmosphere. It caught a faint spectral line in the infrared, the signature of CO2 frozen once again, refreezing as the comet drifted into the cold. Its breath turned to silence, its vapor to frost, its motion to solitude. And with that, the traveler fell quiet. But in the memory of its breath, in those fragile molecules recorded across sensors and spectrographs, humanity had glimpsed something humbling, that even in the void between suns, where light takes centuries to find a home, there are still things that remember how to breathe. When the light turned green, the world finally began to see it. Before that, 3I Atlas had been only a whisper, a speck of data on astronomers' monitors, a rumor in scientific circles. But when the images began to circulate, real photographs taken from telescopes across both hemispheres, the traveler's identity changed. It was no longer just a comet. It was an apparition, a sphere of emerald fire drifting through the dark. The color was unmistakable, luminous, unnatural, mesmerizing. A green that didn't belong to life nor to decay, something colder, older, purer. It wasn't the soft jade of Earth's forests or the electric pulse of neon. It was the green of chemistry, the hue of molecules shattering under starlight. Spectroscopic data revealed the culprit, C2, diatomic carbon, born from the breaking of organic chains and carbon-rich dust. When sunlight hits these fragile molecules, they fluoresce, glowing green in a way that no solid object ever could. On paper, the physics was simple. In the human mind, it was terrifying, because no one had ever seen a glow quite like this. So strong, so far from the sun, so alive. Under the long exposure of the cameras, the light seemed to pulse, to breathe. In time-lapse videos, the entire coma of the comet appeared to throb like the iris of a waking eye. The media called it the green flame. It spread across the internet faster than any discovery before it. Images shared, enhanced, filtered into surreal gradients of color. Most viewers found it beautiful. Some found it haunting. A few, quietly, found it hard to look at for long. Even among scientists, the reaction was mixed. The data explained the hue, yes, but not the intensity. The C2 fluorescence was stronger than any model predicted, amplified far beyond what could be caused by sunlight alone. Something inside the comet was feeding it, accelerating the chemical dance. Elena Voss wrote in her log, "It's as if the comet isn't reflecting light. It's producing it, a cold flame, sustained by memory rather than heat." Astronomers on Mauna Kea stayed awake for nights, watching the emerald glow intensify as the comet rotated. Through the thin air and the hum of the observatory's tracking motors, they saw faint streams of gas twisting outward, not chaotic but rhythmic, like jets fired in time to some unseen metronome. Each jet released new carbon molecules into space, and the green shimmer bloomed anew, like embers rekindled by a breath. It wasn't constant. It flickered, faint, then bright, then faint again. Every 15 hours, matching the object's rotation. The same rotation that had revealed its broken shape now became the heartbeat of its color. The light, the spin, the breath, all synchronized in a harmony of physics and awe. And yet, there was something deeply unsettling about it. Because to human eyes, the color green has always meant life. And here it was, life's color, burning on something that had never lived. As the comet approached its perihelion, the glow grew so intense that even unfiltered long-exposure photographs showed a halo of light surrounding its nucleus. The tails split in two, one of dust, one of gas, and both shimmered like twin streamers of phosphor in the void. In some frames, the tail seemed to bend toward the sun, not away, an illusion of perspective, perhaps, or a subtle dance of charged particles in magnetic currents. But to those who watched from Earth, it looked like the comet was turning to face the light. And the world, watching in silence, felt the same. The spectral lines continued to puzzle scientists. Alongside the bright C2 emissions, there appeared faint traces of CN, cyanogen gas, another common but ominous presence in cometary chemistry. In the 19th century, when cyanogen was first detected in comets, newspapers had terrified the public with stories of poisonous tails sweeping over Earth. Now, in the age of reason, those fears had faded, but the symbolism lingered. Green light and cyan gas, death's colors, rendered in beauty. One journalist wrote, "It glows with the color of life, but breathes the chemistry of death." In Chile, Eleanor and her team used a high-resolution spectrograph to map the distribution of the glowing gas. They expected a smooth coma, a soft sphere of evenly distributed carbon. Instead, they found turbulence, knots, and voids, chaotic vortices of gas swirling in unpredictable eddies. The emission wasn't random. It formed filaments, threads, delicate structures suspended in emptiness. Someone on her team compared it to neurons, a glowing web of connections. Someone else joked that it looked like a brain made of starlight. No one laughed for long. The shapes were fleeting, dissolving within hours. But the idea stayed, that even chaos can imitate pattern, and pattern meaning. The human brain is helpless before pattern. We see faces in clouds, constellations in stars, intent in motion. So when the green flame of 3I Atlas pulsed across the sky, it was inevitable that people began to see messages. Videos circulated claiming to detect regular sequences in its flicker. One amateur radio operator swore that his equipment picked up faint electromagnetic pulses in sync with the light. It wasn't true, just solar interference, but by then it no longer mattered. The story had outgrown the science. The comet had become a symbol of something vast, alive, watching. For the scientists, though, the meaning was subtler, deeper. The green flame was a window into history, a chemical echo from a world that no longer existed. Its glow told of ancient radiation fields, of cosmic rays that had sculpted its chemistry over millions of years. Each photon of green light was a story of survival, the song of carbon molecules that had endured interstellar exile and still remembered how to shine. Elena summarized it in her final report. 3I Atlas does not reflect our sun. It reflects every sun it has ever passed. Its light is a record of journeys, a spectral diary of the galaxy itself. When the comet began to fade, the green glow dimmed slowly, like breath leaving a body. Photons continued to reach Earth for weeks after it was gone, each one a dying ember of the flame that had once burned cold across the stars. People forgot the physics, but they remembered the color. That strange, impossible green, the hue of something that lived between light and silence. And long after it vanished from our telescopes, those who had watched it could still see it when they closed their eyes. A ghostly fire drifting through the dark, burning without heat, alive without life, leaving behind the question that light always asks when it dies. What else out there still remembers how to shine? Deep beneath the emerald glow, beneath the plumes of gas and dust, there was something solid, something that refused to yield to heat or distance. Every comet has a heart, but the heart of 3I Atlas was unlike anything we had ever known. No telescope could see it directly. The nucleus was hidden inside its luminous coma, a core wrapped in vapor, a secret protected by light. So the scientists began to infer, to imagine by measurement. Every flicker of brightness, every spectral shift, every change in trajectory was a clue. And slowly, through mathematics and patience, an image began to form. Not a picture, but an idea. It was not smooth. It was not whole. It was a relic, shaped by violence. Models suggested an irregular core, jagged and fractured, perhaps the result of ancient collisions. One hemisphere brighter than the other, a complex rotation, tumbling chaotically, never spinning the same way twice. A graveyard of craters, ridges, caverns of ice that had never seen light. The density, estimated at barely 0.3 grams per cubic centimeter, meant it wasn't solid rock, but a porous labyrinth of dust and void, a cathedral of emptiness. Elena Voss studied the thermal data for days before saying aloud what no one wanted to admit. "It's falling apart," she whispered. "It's not a body, it's a memory." And she was right. In the ultraviolet images, faint jets burst from its cracks, narrow, chaotic, coming from beneath the surface layers. Each jet carried carbon dioxide and carbon monoxide, vapor escaping through fissures that might have been millions of years old. Every breath it took was a sigh from a dying structure, exhaling its history into the void. Some compared it to a crumbling glacier, others to a corpse returning to dust. But there was also another theory, darker and more poetic, that what we were witnessing wasn't decay at all, but renewal. To understand why, one has to imagine the journey it had endured. A fragment torn from its birth star's outer disk, perhaps during a planetary collision, ejected by gravity, hurled into the emptiness between suns, its surface bombarded by cosmic rays for millions of years, molecules shattered, atoms rearranged. The outer layers became armor, blackened and inert, but deep inside, beneath kilometers of irradiated crust, the old chemistry might have survived, frozen, preserved, waiting. When the sun's light touched it for the first time, it didn't just warm it, it woke it. The trapped gases expanded, fractures deepened, ancient veins of volatile ice began to breathe again. The comet was not dying. It was remembering how to live. The internal composition told its own story. High CO2 and CO meant it had formed in an environment of deep cold, far from any warm star, where carbon dioxide condensed as solid rock and water was scarce. The trace isotopes hinted at a weak stellar wind, the signature of a small, faint sun. Somewhere, long ago, this object had circled a red dwarf, a quiet, dim star whose light never reached our eyes. That system might have burned out millennia ago, its worlds frozen and gone. And yet here, within this fragment, its chemistry still whispered its name. Elena's team began to call it the fossil of another dawn. They imagined its interior, layers upon layers of ices, each one a page in a story older than Earth. Ammonia, methane, carbon dioxide, dust from the interstellar medium, all compressed and mixed, fossilized into glassy veins. Some simulations even suggested cavities large enough to trap frozen gases that could, under pressure, ignite minor eruptions. Tiny, natural heartbeats, a pulse beneath the silence. What fascinated scientists most wasn't what they found, but what they didn't. There was almost no silicate signature, none of the rocky fingerprints that mark comets from our system. Instead, its mineral content was nearly pure carbon and frozen volatiles, a composition closer to interstellar dust than to planetary material, as if the comet had never truly been part of any world, as if it were the raw clay of creation itself. To hold such purity after millions of years adrift was almost impossible. Yet there it was, a heart of primordial matter, untouched, unchanged, the first solid thing the universe ever made. During one observation session, Elena stared at the spectrographic output, the data scrolling endlessly down the screen. She thought of the difference between a fossil and a seed. Both are old, both are buried, but only one can bloom again. What if, she said softly, to no one in particular, this isn't just a relic of where it came from, but a vessel of where it's going? Her assistant frowned. You mean it's carrying something? She shrugged. Matter, memory, maybe life, maybe just the chemistry for it. The line between death and potential is thinner out here than we think. Some researchers at NASA speculated that interstellar comets like 3I Atlas could act as vectors, carrying prebiotic material across the galaxy, a mechanism for panspermia, the scattering of life's building blocks from one system to another. It wasn't proof. It wasn't even consensus. But the possibility was enough to make every observation feel sacred. The idea that a fragment of another world could wander into ours, carrying within it the ashes or the seeds of a forgotten genesis, blurred the line between science and theology. In that blurred space, humanity stood once again at the edge of understanding, staring into the black heart of a stranger and wondering if, somewhere inside, it was staring back. In one of her later journal entries, Eleanor wrote, "When I think of 3I Atlas, I imagine not stone, but a library. Every molecule a letter, every isotope a word. Somewhere in that frozen code is a memory of another sky, another sun, another dawn that has already ended. And if we listen closely, maybe we can still hear it beating." By the time the comet began to recede again into the dark, most of its details were already lost to distance. The data grew thin, the signals faint. But the mystery of its heart remained, an unbroken silence at the center of its light. Neither ice nor stone, but both. A paradox of fragility and endurance. The last recorded brightness curve showed a faint rhythm, a slow dimming, as if the object were closing its eyes, and perhaps, in its own language of gravity and chemistry, it was dreaming of the star that once gave it life and of the countless suns it would never see again. They watched from every corner of the earth, in deserts and mountaintops, in frozen domes and floating observatories. Men and women sat beneath the stars, bound together by a single thread of light. Each night, they turned their mirrors toward the same direction, and 3I Atlas, indifferent, radiant, turned toward none of them. Field log, Cerro Tololo Observatory, Chile, 0241 UTC. Sky clear, seeing excellent. Object magnitude fluctuating, green hue visible to the naked eye through long exposure. Operator note, it feels alive tonight. In Hawaii, under the black sky of Mauna Kea, the Gemini North Telescope hummed with cold precision. The control room was quiet, except for the whir of cooling fans and the occasional murmur of coordinates. They were professionals, disciplined, detached, yet something about this object broke through the walls of method. Even the most logical among them spoke in metaphors. "It's not moving," one said. "It's drifting, like a thought." Another, younger, replied, "Feels like it's looking back at us." They laughed, because that was safer than silence. Excerpt. Email from Dr. Yasuko Takeda, Tokyo National Observatory. Subject. The pulse. I've confirmed the same fluctuation we noticed last night. Every 15 hours, brightness dips, then spikes again. Exact rotation period. It's almost musical, like breathing. Maybe we should start calling it rhythm instead of noise. The Hubble Space Telescope recorded its faint tail stretching across 250,000 kilometers, thin, delicate, shimmering with green fluorescence. From orbit, Earth was a curved shadow beneath it, blue and silent. From Earth, Hubble was a ghost, floating in the same darkness, watching a ghost far older than itself. For a moment, they aligned, human machinery and cosmic memory, two mirrors reflecting one another. Voice recording, European Southern Observatory, Paranal. Check the outgassing signature again. No, not the CO2, the secondary. Do you see that? The CN line's increasing. It shouldn't. It shouldn't be that strong this far out. Pause. Christ, it's building pressure. Pause. What if it ruptures? Another pause. Quiet. Then we'll have seen the last breath of a world that never belonged to ours. Night after night, the watchers sent their numbers across oceans, gigabytes of light, every photon catalogued, every variable debated. But as the data grew, so did something unquantifiable. Exhaustion, yes, but also intimacy. They began to talk to it, quietly, half in jest, half in reverence. Stay steady. Don't fade yet. Show us one more secret before you go. It was absurd, speaking to an object that couldn't hear, couldn't care. And yet, in the sterile language of observation, there was warmth. In the silence of the night sky, there was companionship. The comet had become more than data. It was a presence. Private note, Dr. Elena Voss. I find myself waiting for it, as if for a reply. The first time I saw its image, I thought, this is what loneliness looks like. Now, I realize I was wrong. It's what connection looks like, stretched too far for words. From Greenland, an amateur observer sent a photograph to the International Astronomical Union, a grainy, imperfect shot taken through a frosted lens. But there was something raw in it. The green flame, blurred against the polar night, framed by the aurora. No lab image captured that, the meeting of Earth's own light and something born between the stars. The scientists, hardened by precision, stared at it in silence. For a second, data felt sacred. Transmission, Deep Space Network, Canberra, signal relay nominal, cross-linking Hubble and JWST spectral streams, packet lag 3.4 seconds, background noise low, pause. Operator comment. Sometimes I wonder if it's listening. Everything else in space reflects, why not sound? In the chill of the Atacama night, Eleanor's team worked through their 12th consecutive shift. The comet was bright now, its coma wide as a planet, its tail faintly visible even to the naked eye under perfect darkness. One of the interns stepped outside for a cigarette and looked up, and there it was, a green smudge just above the horizon. He stood for minutes, unmoving. When he came back in, he said nothing. But the others noticed his hands were shaking. Excerpt, internal chat, NASA/JPL collaboration server. Harper. The CO2 output's increasing again. When? It's not temperature, that's stable. Harper. Then what's driving it? When? Maybe internal structure collapse. Harper. Or maybe something inside is still warm. When? Warm from what? Harper. From remembering. All across the globe, the watchers shared the same quiet dread. The sense that they were witnessing something final. Not the end of a comet, but the end of their ability to explain. For every answer 3I Atlas gave, it took another away. The great telescopes, Gemini, Webb, Hubble, VLT, became organs in a vast planetary body, their lenses like eyes turned outward in a single gaze. Each one caught a fraction of the truth, each one seeing the same ghost from a different angle. Together, they formed a chorus, the voices of the telescopes. Log, James Webb Space Telescope, December 14, 2025. Object magnitude decreasing. Tail fragmentation observed. Infrared spectrum stable. CO2 line fading. Operator comment. It's quieter tonight, like it knows we're done watching. When the last observation came in, a faint curve of light against the black, The world fell silent for a heartbeat. The data packets stopped. The screens went dark. The telescopes turned away. And for the first time in months, the sky felt empty again. Yet the voices lingered. In archives, in recordings, in notes left half-finished. Tiny human echoes beneath a cosmic silence. Final entry, Elena Voss. Audio log. We think observation is one way, that we look out and the universe stays still. But when you stare long enough, it changes you. I think that's what Atlas was, a mirror. It didn't teach us what the universe is. It taught us what we are when we watch. And somewhere beyond the edge of the heliosphere, past the reach of our telescopes, the traveler continued on, unseen, unmeasured, untouched. But in the observatories it left behind, its light still glowed faintly on the retinas of those who had witnessed it. A memory not of discovery, but of recognition. Science begins with faith, the quiet belief that the universe obeys its own laws, that gravity never lies, that matter behaves, that what happens once will happen again. 3I Atlas did not destroy that faith. It simply refused to acknowledge it. By December's end, the object's path was supposed to be predictable, a clean, hyperbolic arc, charted to the decimal. But small irregularities began to appear in the data, subtle, persistent, undeniable, the kind of errors that no calibration could fix. The comet wasn't where it should have been. Not by much, just a few thousand kilometers off course, but enough to make mathematicians frown. Enough to make the software whisper, impossible. At first, they blamed the gas jets. Outgassing always shifts a comet's motion, nudging it like invisible thrusters, but the direction didn't match. The jets were firing one way. The trajectory changed the other. It was like watching wind push a sailboat against the breeze. Excerpt, internal NASA memo. Non-gravitational acceleration inconsistent with vent direction. Possible mass redistribution within nucleus, or unknown external influence. Recalculate with variable drag, constant. Handwritten note in margin. We've seen this before. Oumuamua. The déjà vu was impossible to ignore. 8 years earlier, Oumuamua had done the same. A mysterious acceleration without visible outgassing, a motion that seemed to defy inertia itself. Back then, the explanations had been desperate. Hydrogen ice, solar radiation pressure, alien sailcraft. Now, with 3I Atlas, the same mystery returned, but colder, clearer, undeniable. Only this time, the object was venting gas. There was nothing invisible to blame. And yet, its motion still broke the math. At the European Southern Observatory, an emergency conference assembled in mid-December. Dozens of teams compared models, overlaying trajectories, analyzing residuals. Every possible factor, solar radiation, solar wind, gravitational resonance, accounted for and dismissed. The numbers refused obedience. Elena Voss sat at the end of the table, silent, watching the projections spiral across the screen like fractal patterns. They looked beautiful and wrong. She finally said, "We're trying to fit it into rules that belong to this solar system. But it didn't come from here. Why should it obey them?" No one answered. But in that silence, something cracked, not in the data, but in the certainty behind it. Soon after, another anomaly appeared. Infrared readings showed that the surface temperature didn't follow the expected curve. It wasn't heating up evenly. Some regions stayed cold, almost inert, even under direct sunlight. Others grew hotter than physics allowed. Thermal inertia models failed. Material composition equations fell apart. One simulation, when extended backward, even predicted a period of internal warming before the comet approached the sun, as if it had already known it was coming. No one believed that, of course, but no one could disprove it either. Excerpt Paranal Night Shift Log. At this point, the comet behaves as though it remembers gravity differently. Not stronger, not weaker, just older, like its mass was trained under another law. The phrase "trained under another law" spread quietly through the astrophysics community. It appeared in late-night discussions, in conference halls, in papers that never reached publication. What did it mean for something to have learned gravity differently? Could matter, shaped by alien suns and alien constants, move through our space in ways that ours could not? If so, the universe wasn't universal. It was regional, fragmented, ruled by local dialects of physics that only seemed consistent because we'd never left home. By January, the deviations grew too large to ignore. Predicted coordinates no longer matched reality. The object accelerated slightly, a whisper of motion. No thrust, no flare. It simply drifted faster. Not toward the sun, not away, sideways, as if slipping between layers of space we couldn't measure. The data analysts called it lateral drift. Philosophers called it escape. Elena stared at the numbers, exhausted, her coffee cold beside her notes. "We're seeing a pattern that shouldn't exist," she said, "like it's moving through something we can't detect." Her assistant frowned. "Dark matter?" "No," she said softly. "Dark law." The phrase caught on. Dark law. Not as a theory, but as a whisper, a term for the unmeasurable principle that the universe hides from us, the one that governs the interstellar. Maybe there were forces that mattered only across gulfs between stars, pressures, tides, or geometries that we had never learned to name. Maybe we were seeing the first trace of that hidden architecture. It didn't feel like science anymore. It felt like eavesdropping on the machinery of creation. The deeper the scientists looked, the stranger the data became. Spectroscopy revealed elements in ratios that broke known stellar models. Some isotopes of carbon and nitrogen appeared almost shifted, not in measurement, but in behavior. They absorbed light differently, as if their atomic rules had been slightly rewritten by interstellar radiation. It was still carbon, still nitrogen-soaked, and yet it wasn't ours. A quiet panic began to spread, not fear of danger, but of ignorance. If matter itself could change its loyalty to physics, what else could? Excerpt Elena's journal, final entry of Act 2. We've always believed in constants, in gravity, in light, in the rules that never bend. But what if constancy is only a local habit of the cosmos? Maybe there are regions where time moves differently, where matter carries instructions from its birth star, instructions that we can't read. 3I Atlas isn't breaking our rules. It's reminding us they were never ours to begin with. In late January, the last reliable measurements were logged. The comet, already receding, faded beyond the reach of human eyes. Its orbit, once so clear, blurred into probability. Its path, once mapped to precision, dissolved into mystery. The data was archived. The telescopes turned elsewhere. And yet, something in the mathematics remained broken. The equations didn't close. The universe, for the first time, refused to balance. Somewhere beyond the reach of all correction factors, 3I/Atlas continued to move. Not faster, not slower, just differently. And in its wake, the one thing it truly altered was not gravity, not chemistry, but certainty. The object had left, but the rules it broke were still here, humming quietly beneath every equation, like a reminder that order is only another kind of faith. There was no explosion, no collision, no cosmic fire to mark the end of the story. In the real timeline, 3I Atlas came and went exactly as celestial mechanics demanded. Silent, graceful, untouched. It passed through our system like a shadow across the face of eternity, and then was gone. It entered the solar system from the south, slicing up through the plane of the planets at an angle so steep it felt deliberate. At its closest, it came within 1.4 astronomical units of the Sun, farther than Earth, nearer than Mars. Close enough to glow, far enough to stay a mystery. Its velocity was extraordinary, more than 200,000 kilometers per hour, a speed no gravity could tame. Even the Sun, that ancient tyrant of motion, could not hold it. The comet passed through its dominion and continued unbound, forever a citizen of interstellar night. For 3 months, the world watched. For 3 months, its emerald heart pulsed against the black. In the southern hemisphere, under pristine skies, the faint glow could sometimes be seen without instruments, a green smear near the horizon, more rumor than light. But to those who saw it, even for a moment, the memory never left. In those months, 3I Atlas became the most observed object in modern astronomy. Every wavelength, every photon, every breath it exhaled was recorded and dissected. Thousands of terabytes of data filled servers across continents, spectra, trajectories, models, maps. Humanity's attempt to preserve an encounter it could never repeat. The comet reached perihelion in mid-November 2025. At that moment, its activity peaked. Jets bursting from its fractured core, carbon dioxide streaming into sunlight. The green flame at its brightest. The tail stretched millions of kilometers into space, a veil of vapor so thin it could have passed through a planet unnoticed. And then, just as quickly, it began to fade. No fragments broke away, no disintegration occurred. It endured its closest approach intact, though intact was a relative word. It shed layers of ice, grains of dust, atoms of memory, tiny pieces of a foreign world scattered into our sky, joining the solar wind, mingling with the breath of our own star. For a few brief days, 2 suns touched through a cloud of alien dust. By December, it had crossed the orbit of Mars again, heading outward. The green faded to gray. The tail dissolved. The breath of CO2 grew thin, replaced by silence. The instruments still caught flickers, a faint pulse, a whisper of reflection. But the traveler was leaving. Astronomers tracked it as long as they could. The numbers became smaller, more uncertain. Each new data point was harder to confirm, each image fainter than the last. And then, one night in late January, The signal vanished into the background noise of space. That was it. No sound, no farewell, just absence. In the months that followed, the research teams published their papers, calm, meticulous, peer-reviewed, each one a brick in the cathedral of collective understanding. They detailed everything: composition, outgassing, isotopic ratios, light curves, the peculiar acceleration that still refused full explanation. No sensationalism, no poetry, just data, the final language of reverence. But beneath the formal tone of those papers, an invisible emotion ran like a current, the sense that humanity had witnessed something that wasn't meant to be witnessed, something that belonged to a different conversation between stars, and that we had overheard by accident. Lena Voss, weary but luminous with wonder, presented the last report of the Atlas survey that winter. Her words were quiet, but they carried the weight of years. 3I Atlas, she said, was not remarkable because it came from beyond. It was remarkable because it reminded us that beyond still exists. We spend our lives mapping the universe, but this was the universe mapping us. The audience of scientists, exhausted and reverent, applauded in silence, the kind of silence that only comes when applause feels inappropriate. For the public, the fascination faded with the season. New headlines replaced it: elections, storms, wars, discoveries closer to home. But somewhere, in quiet classrooms and mountain observatories, the story lingered. Children drew pictures of green comets. Graduate students built models of interstellar dust. And in the corners of research papers, footnotes whispered of non-gravitational anomalies, thermal irregularities, chemical asymmetries, traces of a mystery too large to conclude. The comet itself kept going, past Jupiter's orbit, past the Kuiper belt, where sunlight becomes an afterthought, through the heliopause, where the solar wind gives up and the galaxy begins again. Beyond that, only darkness and stars. There, in the interstellar deep, it became what it had always been: a solitary particle in a cosmic tide too vast to name. A frozen ember, still spinning, still carrying within it the dust of two suns, one that made it and one that let it go. In a few million years, it will pass near another star. Maybe it will be seen again, its green breath caught in alien instruments, its name rewritten in another language. Maybe not. It doesn't matter, because by then, it will still be moving. And so will we. Elena's final note, written months after the comet disappeared, captured the essence of the real trajectory. It came to remind us that we are not alone in motion. Every world drifts. Every system breathes. We are all fragments crossing someone else's sky. And someday, somewhere, another civilization may look up and see a faint green light and call it their own visitor. In the end, 3I Atlas left nothing behind. No fragments, no impact, no message. Only a shift, subtle but permanent, in the way humanity looks upward. The real path was not the comet's, but ours, a curve of understanding bent ever so slightly closer toward infinity. Every story of survival begins with coincidence. And in the cosmic scale, coincidence is measured in millimeters and milliseconds. If 3I Atlas had entered the solar system just 0.07 degrees differently, a deviation so small it could fit within a single human breath, its path would have intersected with Earth's orbit on the morning of December 3rd, 2025. For 3 days, it would have burned across the sky, a green wound spreading light through the atmosphere. For 3 hours, it would have been visible to every eye on the planet. And for 3 minutes, the night would have turned to emerald day. It didn't happen, but it could have. And so the scientists modeled it. The first simulations were mathematical curiosities, exercises in probability. But as data refined, those hypotheticals took on unsettling realism. The parameters were known: a nucleus between 8 and 15 kilometers wide, mass approaching 10 trillion tons, a velocity over 200,000 kilometers per hour, a cosmic bullet forged in another star's nursery. At that speed, there would be no atmosphere thick enough, no magnetic field strong enough to slow it down. Upon impact, the energy released would exceed the detonation of all nuclear weapons ever built, multiplied by 100,000. Not a fireball, not even heat. A pulse, a wave of annihilation spreading faster than sound, faster than comprehension. The models showed the entry angle, 42 degrees, a descent across the Pacific near the equator. The first shock wave would tear through the upper atmosphere, flattening it into plasma. The light would arrive before the sound, and both would arrive before understanding. The green comet would turn white, the color of total energy, and then vanish into the ocean. The sea would vaporize. The crust beneath would shatter. A column of molten water and rock would rise 50 kilometers high, glowing like the stem of an inverted sun. A second sun burning for minutes, then gone. The blast wave would circle the planet twice. By the time it dissipated, the Pacific would no longer exist as a basin. The sky would darken with ash and carbon dust. Within hours, clouds of superheated steam and pulverized stone would choke the stratosphere, wrapping the world in a glowing veil. The global temperature would rise by 15 degrees, then fall by 30. The rain would not fall for months. The oceans would glow at night with phosphorescent death. Humanity, as we know it, would vanish, not from impact, but from aftermath, from silence. And yet, what unsettled the scientists most was not the destruction, but the precision. That such devastation could depend on an angle smaller than the width of a human hair. That life on Earth, all of it, every heartbeat and every breath, could exist or end by a variance too small to measure without supercomputers. The universe, it seemed, balanced existence on decimal points. A single rounding error, and everything changes. Elena Voss never liked running the impact simulations. She called them necromancy through numbers. But she ran them anyway because the what-if was part of the truth. One night, long after the others had gone home, she projected the full scenario across the wall of the observatory's main dome, a digital reconstruction of the Earth on collision day. The comet's green tail stretched across the horizon, luminous, vast, breathtaking. She stood beneath it, alone, and whispered, if this had happened, no one would have seen the second sunrise. Then she turned off the projector, but the afterimage of green light stayed behind her eyelids. It followed her into sleep. For the sake of academic rigor, the team prepared a formal paper, projected consequences of interstellar object collision at 1 AU. It was never meant for publication, only for archives. But the final paragraph read more like scripture than science. We model the end not to anticipate it, but to understand the fragility of continuance. 3I Atlas reminds us that survival is not triumph, only delay. The sky does not need to hate us, to erase us. It simply needs to forget we were here. Some of the younger researchers took the exercise further. They imagined the nights before impact, the global panic, the telescopic confirmation, the disbelief that something so small could end everything so vast. They calculated evacuation zones, defense strategies, even the feasibility of nuclear interception. The results were always the same: impossible. No rocket could catch it. No shield could withstand it. The planet was simply in the way. They called that final scenario the Green Winter, a poetic name for the season that never came. But amid all the hypothetical ruin, another truth emerged: quiet, elegant, humbling. Even in the simulation's darkest moments, fragments of Earth's atmosphere would escape into space, carried by the blast. Molecules of oxygen, nitrogen, and carbon, the chemistry of life, flung outward on the shockwave. In some runs, those molecules formed stable clusters, traveling fast enough to leave the solar system entirely. Tiny ambassadors, particles of a dead Earth drifting between stars, becoming, in time, someone else's interstellar visitor. Elena called that the symmetry of endings. She wrote, "If 3I Atlas had struck us, it would not have been the end, only the inversion. We would have become what it was, a messenger from one lost world to another." The collision never happened. The comet missed by millions of kilometers, a distance so small in cosmic terms it may as well have brushed our breath. But for those who had run the simulations, the memory of that alternate Earth remained. They had seen the green light burning over a dying ocean. They had watched the numbers of extinction unfold in silence. And they had learned the simplest, cruelest truth of all: that existence is not permanent. It is a narrow escape, repeated endlessly, without anyone realizing it. When 3I Atlas finally disappeared into the black, no one celebrated survival. The world had not been spared. It had simply been overlooked. And in the deep halls of the observatories, among the hum of servers and the faint hiss of cooling fans, the scientists whispered to each other, half in fear, half in awe, "The next one will come. And maybe next time it won't miss." It begins with silence, not the absence of sound, but the stillness that comes when everything you thought you understood stops behaving. In this hypothetical model, the one no one dared to publish, 3I Atlas does not collide, nor does it drift away. Instead, somewhere near its perihelion, as it turns its fractured face toward the sun, something inside it changes. Not violently, not visibly, just a shift, too subtle to measure, too deliberate to be random. The data first appears as noise, minor fluctuations in spectral lines, repeating irregularities. At first, dismissed as interference from solar radiation. Then, the pattern becomes persistent. It repeats every 15 hours, the same rhythm as the comet's rotation. But over time, that rhythm begins to drift, elongating, stretching, as if the object were slowing down. only it isn't. The spin rate remains the same. The light, however, begins to pulse independently of it. A second pattern has appeared. By the second week of monitoring, the team notices that the brightness modulation, the green flare of C2 fluorescence, is now synchronized with Earth's orbital position. Not in absolute terms, but in phase. The intensity peaks precisely when the comet is on the opposite side of the Sun from our planet, as if it knows when we are looking and when we are not. Statistical coincidence? Perhaps. But coincidence should decay under repeated observation. This one strengthens. Elena calls it the synchronization. Others refuse to name it at all. Spectral anomalies multiply. CO2 emissions spike without cause. Subsurface jets activate on the comet's dark side, where no sunlight reaches. Radio emissions, faint, structured, begin to register on low-band instruments, buried deep beneath solar interference. They are not signals, not in the traditional sense, but their structure defies noise, a repeating sequence of narrow-band oscillations. Their frequency matches the light curve drift, a harmony of motion and energy. The comet is not talking, it is resonating. Excerpt, internal note, Atlas Research Group. Correlation confirmed between emitted radio band, AA 2.3 MHz, and C2 brightness cycle, amplitude stable across multiple instruments. Source indeterminate. Possibility of internal resonance, electrochemical, crystallographic, unknown. Addendum, Elena Voss. Or it's listening. The phrase "it's listening" appears in only one line of her personal notes, written in pencil, circled twice. But it spreads through the observatories like a contagion of unease, because it feels true. The comet seems to react, subtly but unmistakably, to every increase in observation. More telescopes pointed at it. The emission patterns intensify. Communications silence for 24 hours. The anomalies subside. It's not communication, it's feedback. As if light itself were a trigger, as if attention had become a form of energy. When the James Webb Space Telescope locks on for a continuous 48-hour observation, the pattern reaches its peak. The comet brightens to nearly twice its predicted magnitude. The CO2 lines flare. Then, for a brief and impossible 12 minutes, the light stabilizes into a constant value, perfect, unwavering, unnatural. No celestial object ever holds brightness perfectly still. Every particle scatters, every photon wavers, but 3I Atlas stops trembling. It becomes steady. And in that steadiness, for those 12 minutes, the instruments record something that should not exist, a faint, coherent hum in the electromagnetic background, perfectly centered on the hydrogen line. The hydrogen line, 1420 MHz, the universal frequency of atomic memory. The frequency that for decades humanity has used to search for extraterrestrial signals. The frequency that defines the quiet conversation of the cosmos. It could not be an accident, but it was too perfect to be proof. The team falls silent. There are no exclamations, no theories, just the hum of air conditioners and the faint buzz of electronics. Outside, in the desert, the stars keep shining, unmoved, unconcerned. And somewhere between them, the traveler glows with a green that feels alive. Private Journal, Elena Voss. We are the first civilization to look at something that may be aware of being looked at. If that's true, then our instruments are not windows, they are mirrors, and what we see in that light is not an answer, but a reflection of the act of seeing. As the days pass, the hum continues, not constant, not repeating, evolving. It modulates slightly, introducing harmonics no instrument predicts. The light of the comet begins to flicker faster. The tail thickens, then narrows. Its rotation appears to slow, though the math says otherwise. Spacecraft telemetry briefly records a micro-acceleration opposite the Sun, so small it could be an error. But it happens again and again. It's as if something beneath the surface is stirring. The team stops calling it activity. They start calling it response. Then, without warning, the emission ceases. The light dims to near invisibility. The radio hum vanishes. The comet goes cold. For 3 days, silence. In that silence, the world breathes. And then, on the 4th night, the green flame returns, but dimmer, softer, almost tender. The hum does not come back. The resonance is gone. Only light remains. Afterward, the data is re-examined, reinterpreted, rewritten. The official report calls it a rare electrochemical event triggered by solar wind resonance. A safe phrase, a human phrase. But in private, Elena writes something different. We were not visited by intelligence. We were visited by attention. The universe looked back, briefly, then it closed its eyes again. In this hypothetical timeline, 3I Atlas drifts away, as in reality, outward, silent, its glow fading into the cold. But for those who watched it awaken, the stars no longer look the same, because they know now that the void is not empty. It reacts, it remembers, and somewhere in that infinite memory, the green light of Atlas still flickers, not as a warning, but as a question. What if the universe is not waiting to be discovered, but waiting to be acknowledged? It is the year 3473. The sun has dimmed by no measurable amount, and yet it feels older. The skies of Earth, what's left of them, are still watched, still measured, though the great observatories now orbit beyond the atmosphere. Humanity has learned to travel, to build, to leave, but not to stop looking back. And then, one ordinary morning, the algorithms notice it, a faint, moving speck, green. Again. At first, it's dismissed, a sensor artifact, a fragment of lens flare, a cosmic coincidence. But as more data arrives, the truth crystallizes with terrifying calm. The orbit matches. The velocity matches. Even the spectral fingerprint, the peculiar CO2 and C2 balance, is identical. 3I Atlas. Back again. After 4 centuries adrift in the void between stars. Returning from nowhere. Its inbound vector is impossible. Not hyperbolic, not random. Elliptical. The interstellar traveler, once unbound by any sun, has found a way to return. No known force could have captured it. No gravitational resonance could have slowed it down. For months, scientists argue over the math. The numbers resist logic, bending into patterns that hint at intention, not physics. One hypothesis calls it orbital echo, a phenomenon so rare it borders on absurdity, the object somehow losing velocity due to interactions with interstellar plasma, captured again by the sun's reach. Another calls it recurrent debris mirage, a coincidence of 2 separate bodies with identical signatures. A third hypothesis, whispered but never published, bears a single line in an internal memo. What if it was following the light we sent? The first image from the Deep Array Observatory confirms the visual. The familiar shape, elongated and fractured, wrapped again in the soft green haze. But this time, it glows before sunlight touches it. The old pattern has returned. The premature awakening. CO2 jets already active at 6 astronomical units. The same spectral hum in the hydrogen line. It is as if the comet remembers its last journey, as if it has kept time with us in the dark. The news spreads quickly, but not like before. There is no wonder, no poetry, only unease. Humanity has changed. Older, colder, slower to awe. But even now, the idea of its return shakes something deep in the collective memory. Stories resurface, fragments of the past century's myths, documentaries, whispered superstitions. Children learn the name Atlas again, as if it were an ancient god. On the orbital station, Kepler's Gate, high above Neptune's frozen rings, a team of astrophysicists begins the new observation campaign. Among them is Dr. Nira Voss, great-great-granddaughter of Elena. The name is coincidence only in biology. In meaning, it feels inevitable. She knows the story by heart. The hum, the green light, the strange pulse in the data. Now, she is the one staring into that returning glow. It shouldn't be here, she says quietly, and yet I think it never left. The comet approaches slowly, as though time itself hesitates. Its tail extends, ghostly and diffuse. Its light brightens not from the sun, but from within, as if burning with a memory of its own. The instruments capture once again the impossible steadiness in brightness, no fluctuations, no turbulence, and then, faintly, the hum returns. This time, it is not faint. This time, it is clear. A tone, pure, harmonic, modulated, echoing exactly at 1420 MHz, but not continuous, structured. It is not a message. It is a pattern of silence. Intervals, gaps, spaces, a rhythm that matches one thing only. Human radio transmission intervals, 400 years old. The comet is mirroring us. Extract from mission log, Kepler's Gate Observatory, day 102 of approach. Hydrogen line emission confirmed. Pattern resembles stored waveform from 2025 Voyager comms archive. Delay matches 4-century light travel distance. Impossible correlation. It's not repeating what we sent. It's answering the silence between signals. For months, the hum continues. Not speech, not data, resonance. Like the deep, sustained note of a choir, no one remembers beginning. In its rhythm, some detect the echoes of pulsars, quasars, the heartbeats of the cosmos itself. Others hear something else, something that sounds like intention. When it passes Jupiter, the light intensifies again. Not in bursts, but in waves. The green glow spreads through the coma, flickering like breath. The telescopes record the same phase shift synchronization first noted by Elena centuries ago. The flare peaks when the comet lies opposite Earth's orbit, as if once again it knows we are watching. Nira watches too, sleepless, entranced, afraid. Her logs begin to blur with her thoughts. If it came back, it wasn't to be seen. It came back to see who's still looking. Then, one night, The comet's glow flares to blinding intensity. For 13 minutes, every sensor in the solar system, human or otherwise, floods with signal. The hydrogen line saturates, then collapses. The brightness plateaus at a perfect constant, identical to the 12-minute plateau recorded in 2025. The same precision, the same pause, a repetition, centuries apart, a cosmic inhale. Then the light fades. When the data is processed, the pattern in the hydrogen band is found to encode one simple sequence, a modulation that corresponds to a familiar mathematical form, the ratio of Earth's orbital period to the comet's approach interval, 1/400. The universe, it seems, had been keeping time. When the flare subsides, the comet changes course. Not wildly, not abruptly, gently, as if turning to leave. Its velocity increases by 0.3%, a trivial number in physics, but unmistakably directional. It is leaving again, but this time along a new path, one that will intersect the orbit of another star in another 400 years. It is as if 3I Atlas has become a messenger, moving in measured intervals, pausing every few centuries to look, to hum, to remind. Final entry, Dr. Nira Voss. It doesn't speak in words, but in returns. It remembers us not through sound, but through the act of being witnessed. Maybe it has no purpose at all. Maybe it simply carries the memory of attention, the echo of being seen. But if that's true, then every gaze into the dark is a promise, and every light that comes back is that promise being kept. The traveler departs again. Its green flame dims beyond Neptune, beyond Pluto, into the place where sunlight is only myth. But humanity, for the first time in centuries, does not look away. The great telescopes stay fixed on the void long after the glow has gone, as if waiting for the next flicker, the next heartbeat, the next return. And somewhere in the black between stars, the echo of that green light continues to move, not a warning, not a god, not an omen, just a reminder that the universe never truly forgets what has once been seen. The memory of light. In the end, it was never about the comet. It was about the way we looked at it, the silence between our breaths when we tried to name something older than language. 3I, Atlas came, it burned, it vanished. But the thing it awakened, being the ache of awareness, remained. The memory of light is the only thing the universe keeps. Everything else decays. Matter, sound, certainty. Only light endures, wandering endlessly through cold space, carrying with it the story of what once was illuminated. When we look at the night sky, we see ghosts of stars long dead. We know this, and yet it still moves us, because deep down we understand that memory is a kind of survival, and that to be seen, even once, is to never entirely disappear. Atlas was seen. For a few brief months, humanity turned every mirror in its possession toward that cold traveler, and in doing so left an imprint on it, not physical, but existential. Light met gaze, and something in the space between them became real. Perhaps that's all life is, a collision between attention and matter, between the act of seeing and the thing seen. When Elena Voss wrote her final notes, she ended with a sentence that no one understood at the time. Observation is not passive. It is the universe folding itself into awareness. Centuries later, her descendant, Nera, would write the same thought again, almost word for word, as if the idea itself had survived like radiation across generations. The universe remembers not what it creates, but what it looks back at. Between those two statements lies everything humanity ever learned, and everything it ever feared. The story of 3I Atlas begins with discovery, passes through understanding, and ends in reflection. Not because the object was extraordinary, but because it revealed the extraordinary in us. We thought we were studying a comet, but we were documenting the first conversation between light and consciousness, and that conversation is still happening. Every photon that leaves a star, every reflection that bounces off a world, every pair of eyes turned upward, they are all part of the same sentence, the grammar of existence, the syntax of wonder. Even now, centuries later, its light is still traveling, through dust, through void, through the endless ocean between suns. Somewhere out there, it is passing another world. Perhaps that world has no sky. Perhaps it has no eyes to see. But if it does, if something there looks up, then for a heartbeat, the chain continues. And in that heartbeat, everything that ever existed remembers itself. There is a concept in old physics, photon entanglement, the idea that once two particles of light have met, they remain connected, no matter how far apart they drift. It was once a paradox. Now it feels like prophecy. Because when 3I Atlas passed through our solar system, a few of its photons scattered across our instruments, our skies, our eyes. Those photons are still entangled with us. We carry them now, in data, in memory, in metaphor. And perhaps, in some strange cosmic arithmetic, we are still linked, still resonating, still echoing across the black. Every civilization will have its visitor. Every thinking species will one day look up and see a light that does not belong to its sky. And when they do, they will feel the same pull we did, the vertigo of recognition, because to see the unknown is to remember that we are part of it. That is the true legacy of the traveler. Not fear, not awe, but continuity. A reminder that attention itself is a force, that to look is to give meaning, and to be seen is to become real. Somewhere beyond the Kuiper Belt, beyond the heliopause, beyond the reach of all our maps, 3I Atlas drifts still, silent, ancient, unbroken. Its green flame long extinguished, its dust now mingling with the galactic tide. But if light has memory, and it does, then it carries with it the reflection of our world, a small, fragile sphere that once looked back and whispered, "I see you." And that whisper, once uttered, can never be taken back. All light is memory, wrote Elena Voss, and all memory is light trying to return home. That is how every story ends, not in darkness, but in recognition. The visitor came, it left, and in its absence, we discovered the truth that every civilization must one day face. We are not the observers of the universe. We are the part of it that learns to look back.